Alright, so for this one, I think this is page 6. Which transformation would make this one go to this one? This would just be a reflection over this line. I think they're just looking for a single answer, so this is just going to be a reflection. You can't do a rotation, because if you rotate this point always has to be first, and that small point, this point right here is this one. If that makes sense, if you're taking this whole thing and rotating it, this side would always have to be in front, and it looks like it's behind here. So it says select all, so there's more than one answer. So if you were to rotate this thing like about its center, 180 degrees, it looks like you would get this one. See if I can actually do this for this image. Oops. So you get that one. So the rotation works. A glide reflection, meaning like could you translate it, or this is a translation plus reflection. That's what a glide reflection is. Doesn't look like you could do that, because even if you moved it around and like moved it over here and then reflected it, this pointy side would be on the opposite side than this one. Rotation of 90, then a reflection across a vertical line. If you rotate this thing 90, this point would be like here, or it would be here. So then if you reflect it over this, it'd be here or here. So that wouldn't work. Reflection across horizontal line. You got the top here. Then a rotation of 90. I still don't think that would work, because then if you rotate it 90, the flat part would be here, or if the flat part would be here. If I reflect it over here, you still have the flat part here. Rotating it 90 would make it here or here. A double reflection. So across a vertical line would look something like this, and then across the horizontal, that looks like that would work. Double reflection would work. So A and E. This triangle is congruent to PQR. So how you can do this is like look at each side. Let's go from P to R, 1 to 2. So we're looking for what is another triangle that maybe has another way of getting from the smallest side. So I'm looking at this. I go down 3 over 1. That's 3, 1. This is 1, 2. That doesn't work. This is 2, 2. That doesn't work. Here's 2, 1. That looks like it's going to work. And both of the other sides we get, oops, we do this in a different color. We got 2, 3, 2, 3, and then we got 3, 1, 1, 3. So that works. This ADE would work. Okay, so we have the vertices of this triangle, under which transformation is the image not congruent. This is a nice review of rigid motion. So this is a vocab word that means the object stays the same after you do something to it. So that's true after translation. Like if you translate an object, it's still the same one. If you rotate an object, it's still the same object. If you reflect the object, it's still the same. The only thing that is not rigid is a dilation, right? Because a dilation shrinks or expands it. So a dilation would double the size of it, which means it's not going to be congruent anymore. Okay, so this is a transformation, this is a dilation, this is a dilation, this is a dilation. Look, it's doubling the x value. It's like um, it's like if you had this, you're making it twice as fat. Double the y value. If you had this, you're making it twice as tall. Double the x and the y would look like this for that. So this is it. That's a translation. So a dilation creates similar shapes. Like the angles are still the same, and the sides are all proportional. So this still congruent makes it similar. So it's asking, will the image be similar to the object? So the no answers are incorrect, so we know it will be. And so yes, any number of rigid motions and dilations will always produce an image similar to the pre-image. That is the answer. Yes, since only this doesn't mean anything. Yes, since only 3 transformations were applied, the image. What if the 3 transformations were all translations? It would be congruent. Like the number 3 doesn't have any significance. So there's just like no real evidence to anything.